Okay, so basically, boy throws a ball, follows a path as shown there, and what I'm trying to find ultimately is what is the coefficient of restitution at point A, right? Because my ball comes in with a certain velocity, then rebounds with some other velocity going out like that. Again, my line of impact is going to be perpendicular to that surface. This is going to be my line of impact. So really what I need to know is the vertical velocity coming in and the vertical velocity going out, and from that I'm going to be able to figure out what my coefficient of restitution. So I have to do some projectile motion here, okay? And with projectile motion I always start with my x components, so I'll say x equals x naught plus v naught x t, right? So if I can find the time it takes to do this stuff, I should be able to figure out kind of what's going on here. Now, the x traveled is going to be 7.5, right? 2.5 plus, not 2.5, 2.25 plus 5.25, okay? So this goes 7.5. My initial x I'm calling 0, okay? So that's going to equal basically my initial velocity times t. So this is what I'm going to call equation 1, okay? And that's going to help me find the horizontal velocity and the time, okay? Now, we're going to move on because, again, I'm looking for vertical velocity. So I'm going to use the equation of Vy equals V naught y minus gt. Okay? So again, what I get here is I can find that initial velocity. Okay? So I'll call that Vy1, right? This is right before point A there. Okay? And that's going to equal negative 9.8, which is gravity times time. So again, if I can find time, now I can find my velocities, right? Both the horizontal velocity as well as the vertical velocity. Okay? So I need one more equation to help me find time, and that is this equation, which is y equals y naught plus v naught y t minus 1/2 gt squared. So again, my final y, right, this is bouncing on the ground, so it's 0. My initial y is 0.6. My initial y velocity is 0, right? Because, again, he's throwing it perfectly horizontal, just like we did previously. This goes to 0. That goes to 0, okay? So that's going to equal minus 1/2 times 9.8 times t squared, right? So this is essentially equation 3. From equation 3, I can find that my time is 0.35 seconds. Okay? Now that I have that time, I can find that the y velocity right before impact, which I'm going to call 1, is negative 3.43 seconds. Again, or not seconds, meters per second. Okay, and again, negative because it's going downward, which makes sense. Okay, and my x velocity, okay, my v naught, which is essentially my vx, which is essentially constant through the whole process, right? It says you can neglect the friction, so my velocity, my x velocity stays constant through the entire process. Okay, and that equals 21.4 meters per second. Okay. So that gives me, now I know that the x velocity, which remains constant through the whole process. I know Vy right before impact. So now I'm looking for the velocity right after impact. Okay. So again, I'm going to start with that y equation, okay, to go to point B, which is, I guess I don't really, yeah. Okay, yeah, we'll do that, sorry. So my y is 0.2, right? My initial y is 0. Now, my y that I'm looking for, this is again going to be Vy2, right? This is the velocity after impact. That's really what I'm looking for, okay? That's going to be times time, okay, minus 1/2 times 9.8 times time squared. So if I can find how long it takes to get from A to B, I should be able to find the velocity right after impact, which is what I'm looking for. This is, again, that third equation that I used over on the other side. So I'm going to use my x equation to finish this out. So I go 1.5, so we'll call this, I guess, equation 4. Equation 5 is going to be right here. So again, my x distance traveled is 1.5, okay? And again, my velocity is constant at 21.4. Again, my horizontal velocity, okay, times time. So from that, I can learn that the time is 0.07 seconds. I can plug that into number 4, and I can find Vy2 equals 2.06 meters per second. So this is really just a lot of, at this point, this is just a projectile motion that I'm dealing with here. But now I know the velocity coming in and the velocity going out in the y direction. X velocity, again, remains constant through this whole process. So now to find my coefficient of restitution, again, I just take the final minus the initial. I should say the difference in the final over the difference in the initial. So it's 2.6 divided by 0, and then 0 minus a negative 3 point. Okay, so with this coefficient of restitution, again, ground never moves, so that's why I've got the 0 there, right? So it's the velocity of the ball minus the velocity of the ground, which is 0, all over the velocity of the ground minus the initial velocity of the ball in the y direction, again, along that line of impact. And from that, I find that my coefficient of restitution is just 0.6. So again, a lot of projectile motion, but again, the final idea is find the velocity coming in, the velocity going out, and I can easily calculate my coefficient of restitution just by the difference in the final velocity over the difference in the initial velocity. Again, that would be perpendicular to the ground. Okay, ground doesn't move, so it's just really velocity in, velocity out. Gives me that 0.6.